Astronomy is largely the study of light from distant places. Each kind of light carries different information that adds to our picture of the universe. The upcoming Nancy Grace Roman Space Telescope will detect a key range of light for studying the universe, visible into near-infrared. Infrared, which starts at a wavelength of about 0.75 microns, will allow the Roman Space Telescope to make many critical observations. Roman engineers now plan to add a new filter, extending its range from 2 to 2.3 microns. This seemingly small change will make a big difference. Our galaxy, the Milky Way, is filled with bands of dust and gas that block our view of the stars behind them. Part of what makes infrared light so useful to astronomers is its ability to travel through this gas and dust. Infrared light has a longer wavelength than visible light, which means it is less likely to be scattered and absorbed by small dust particles as it travels over long distances. Upgrading from 2 to 2.3 microns allows astronomers to see through 2 to 3 times as much dust. This opens up much more of our galaxy to study, including surveys of small, dim stars that glow mostly in infrared. Infrared is also good for studying the more distant parts of the universe. As the universe expands, it stretches the wavelengths of light along with it, a process called redshift. The farther away an object is, the more the light from it has stretched by the time it reaches us. Distant galaxies have all of their visible light shifted into infrared. Stretching over distance makes redshift one of the key tools for measuring the universe. Since astronomers can usually determine what wavelength they would see from up close, they can tell how far a galaxy is by how much the light has changed. Closer to home is the search for water within the solar system. Water ice absorbs specific wavelengths of infrared light, providing a fingerprint of its presence. As telescopes see farther into the infrared, they can see more of this fingerprint. If objects in the outer solar system, such as rocky fragments in the distant Kuiper Belt, contain water ice, light reflected off them will have gaps where the water has absorbed that wavelength. This allows astronomers to detect water at much greater distances. The Nancy Grace Roman Space Telescope will form an unprecedented partnership with Hubble and the James Webb Space Telescope. With its extremely large field of view, Roman is uniquely equipped for large surveys of the infrared sky, allowing astronomers to identify interesting targets for more detailed study using Hubble and Webb's overlapping wavelength ranges and smaller fields of view. This collaboration will usher in a new era in infrared astronomy. The Wide Field Instrument is the heart of the Nancy Grace Roman Space Telescope. It is what allows the Roman Space Telescope to take pictures with the same detail as Hubble, but covering an area 100 times larger. Despite this incredible power, the basic design is the same as telescopes around the world. Light enters through Roman's 2.4-meter aperture and is reflected and focused by the curved main mirror, which is also the largest mirror in the telescope. This light is reflected and focused once more by the secondary mirror. More elements tighten the beam and strip it of stray light rays before it passes through the filter wheel. This wheel has a variety of filters that allow different wavelengths of light to pass through. It spins from one to another depending on what the researcher is looking for. Finally, the focused and filtered light reaches the focal plane, where it creates an image on the detectors. These detectors use the photoelectric effect to convert photons into an electrical signal that is then decoded into an image. In Roman's case, there are 18 detectors, allowing it to create 300 million pixel images of large patches of the sky. The large number of detectors and pixels gives Roman its wide field of view. The size of the mirror and the precision of its optics gives Roman its fine imaging. This combination of image size and detail has never been possible on a space-based telescope before, and will make the Nancy Grace Roman Space Telescope an indispensable tool in the future.